Welcome to Bourbon with the Editor. I'm Dennis Spaeth, publisher, owner of Cutting Tool Engineering magazine, and we're here tonight for a special episode of Bourbon with the Editor. Got my editor at large, Alan Richter, who's been with this company for about 80 years.
Feels like it.
How many years?
26.
26 years. Alan's a great guy, good editor, prolific, and has this industry down. I will say that. No, you never have. No one ever has it completely, because it's always changing. But man, you've been there the whole time and on it, and I appreciate that a great deal. Gisbert Ledvon.
You got it right.
Thank you. And did I mention Dennis Spaeth with a weird sense of humor? But Gisbert, Vice President, HEIDENHAIN Corporation. But your title is actually for digital let's go in order. Machine tool, end user, and digital manufacturing. It's a long title. It's not actually your title, but it's what you do there.
That's correct.
So Alan, I'm going to leave most of this episode to Alan, but to kick this off, I want to ask Gisbert to tell us the meaning of life. And
Sure.
God, I got to stop this. My son is probably going to be mad, but tell me a little bit about that background for that title.
Yeah. So it's really encompassing what we do at HEIDENHAIN. So the machine tool world is where we do deliver our components. Then the end users are the people who use the equipment, and we training them, we're helping them to get better at using that. And then the digital manufacturing is really something what puts it all together, making sure that all the peripherals, that all the components, what can help efficiency and monitoring machine efficiency, we bring that all together, and we train people to use that and improve their competitiveness.
Very cool.
Yep.
I mean, that you had a hand in designing your scope.
Yeah, that's correct.
Okay, that's a great scope. Now, Alan, I'm going to ask you if you would share with our listeners and any viewers out there. Tell us a little bit about this bourbon we're drinking tonight.
Oh, yeah, the featured bourbon for tonight is the Colonel E.H. Taylor Small Batch. And this is it's 100 proof. And as founding father of the modern bourbon industry, Colonel Edmund Hayes Taylor Jr. left an indelible legacy. His dedication to distilling, it began with the purchase of the old-fashioned copper distillery in Frankfort, Kentucky. So, and the rest is legendary.
Thank you for that commercial intonation. That was great. Indelible. I love that. But anyone who drinks bourbon is going to be indelible after a couple of drinks. So we're going to cover a little bit of ground tonight, but we're going to keep it free form, obviously, because we're inviting Gisbert to. Alan, why don't you explain to everyone how it came about. Why we?
Well, yeah, I was at Automate, the trade show at McCormick Place in Chicago, and we were at a networking event. This was put on by the what is it? The German American Chambers of Commerce, and ran into. We've had a long relationship and caught up. And what's your relationship with that organization?
So the German Chamber of Commerce had an event there last night, and they tried to show German visitors or investors to see what the United States does when it comes to automation, what factories we have around. So we did some different tours, and then we ended up at the place where we met.
Yeah. Well, and we have certainly another big trade show coming up, a little bigger than Automate, probably, is IMTS, and HEIDENHAIN will be exhibiting there. And I wanted to cover some of the featured products that you're going to be presenting and demonstrating. And I wanted to start out with this is a new one, the MILLPWR control. And I see this is something to make modern CNC capability more approachable. Can you elaborate on what you mean by that? Is about easy to learn, intuitive, something I take it this is where if companies are bringing in newer people, they need to get up and running fairly quickly.
Yeah, so this is actually our ACU-RITE product. And the ACU-RITE product is a product what we make here in Schaumburg, and it has inside the HEIDENHAIN hardware components. But the interface is designed by American research and development guys who have a better feeling of American machine tool users or operators in the shop, right? So what we did, we had a version before where you had a lot of, let's call it buttons, you have to push in order to make a machine work. In this version, we went to a touchscreen technology. And the reason why we did it is we want to attract more younger people into the shop and make it easy for them to interact with the control. You can do programming with conversational, so it's asking you questions if you want to machine a pocket or drill holes. It will automatically write the cycle for you, basically. You can also look at tutorials on there, learn how to do certain things, speeds and feeds. But the big thing is really the touchscreen. We want to make sure that we engage with the younger generation of operators. And this product goes actually on entry-level machines, like a manual machine. You could upgrade with the MILLPWR control. So let's say you have an older Bridgeport in the shop, and you want to teach somebody, either somebody in the school or in the shop, to learn machining. So the first thing you do, you crank your handles and you machine something, get the feeling for it. And then you can use the control to read each axis position. Or you can go as far as, like I said, you can program a cavity, a motion you want to do, drilling holes, tapping holes, and it will do that automatically for you. Yeah.
I see. And I mean, is that similar to graphical programming, or how is that? What distinguishes that?
Yeah, it's pretty much what you would describe as graphical programming, but you talking to the control asks you certain questions, right? How wide is your cavity? How deep is your cavity? What cutting tool will you fill out? Will you use? And you fill that out, and then it basically writes the program for you, and then it graphically shows you how that looks on the screen in your finished part. So before you're machining, you can really see what it looks like. So it's a really great learning tool.
I want to just say that what is the significance of that you have that ability to see that? Because otherwise you'd have no concept of it. So someone new or even as someone who's been around for a while would appreciate this. Can you and then I want you to answer, or just give everyone an idea of the breadth of your background and experience, because you've got a long history in this industry, and you started out tool and die.
Yes, I did.
Right?
Yeah. So yeah, maybe we start there. So I started out in tool and die. I did my apprentice in my apprenticeship program in Germany as a tool and die maker. So 3.5 years you're doing it hands-on and school at the same time, right? Yeah. And I was really fascinated when I had finished my apprentice program by a technology what is called EDM, electrical discharge machining, right? Because as a tool maker, you need to have a certain precision, you're filing, you're grinding, making sure parts fit together. But with a wire EDM machine, you just program the shape you want to machine, and then within a couple of microns accuracy, it machines any type of material as long as it's conductive. Right? So I was very intrigued by this. And so I said, I want to get into this. And if you put a mind to something, you usually get where you want to go. Right? And I got in there. So I worked first in the shop, and then I worked for the machine tool builder, Xiaomi Technologies, in Germany. Yeah.
In Germany you did.
In Germany.
Yeah.
And then in '93, somebody you might know, Harry Moser, he brought me in this case, over from Germany to work here as an application engineer. For Xiaomi Technologies. And that turned then into LG Xiaomi, GF Machining Solutions. Today it's United Machining.
Right? So you skipped a couple, I think.
yeah, we did. There was a
a few others.
Period. So I worked there basically for 29 years in different capacities.
Wow.
EDM, milling, 5X milling. I got a little exposure to additive manufacturing, working together with EOS, and then automation with Systems 3R. So multiple technologies all under one umbrella, if you want, right? So I learned a lot. And then in 2017, I got approached by HEIDENHAIN to join their team and build a team of application engineers to train and help the end users to learn more about 5Xs. Yeah, and that's where I am today.
I'm sorry, Alan.
Yeah,
I will hijack this whole thing, but you got to keep me in check. Ladies and gentlemen, this is my second one. Okay. Why were they focused on the end users? Can you elaborate why the focus was they came to you for that at that time?
Yeah, so I think HEIDENHAIN controls are very high-end CNC controlled, specifically in the 5-axis. So on most high-end 5-axis machines, you will find a HEIDENHAIN control, motion control. So the United States is in a shift of more competitiveness when it comes to manufacturing. And 5-axis is a key component for it. Now, you don't have a lot of operators who have knowledge about HEIDENHAIN or 5-axis for that matter. Okay. So we want to make sure that we educate and help the shops to make that step into 5-axis, helping the operators to switch from simpler control to a more sophisticated 5-axis control. One setup, machining 5 sides, 3+2, or 4+1, or full 5, right? So that was the idea from HEIDENHAIN, Germany, to help the market so that at the end of the day, people would specify more machines with HEIDENHAIN controls because they feel comfortable to operate them, right? Okay. So that's how that came about. And that's where we have now 2 technology centers, one here in Schaumburg, Illinois, the other one is in Fremont, California. And that's where we have class classes for different levels, beginner, high-end, 5-axis application, touch probe classes. So everything what has to do with 5-axis application. Yeah.
Yeah, I think it's amazing. Do you oversee this stuff in California as well?
Yeah, I'm involved in that too. Correct. Okay. Yeah, we have our office there, but there's also a space what we call Connect Manufacturing Innovation Hub. And that's a space where we're bringing different technologies beyond Heidenhain technologies together. So we want to expose schools, people who want to get into the industry to manufacturing technology. And not everybody has the money to buy a full 5-axis or a robot or anything like that. So we put that in the space and we offer seminars, we bring people together so they can work on it, and we show them how to advance in manufacturing. Yeah.
So yeah, you mentioned about the 5-axis machining. I imagine that's an area that's growing as there's more complex shapes that are needed to be machined, and I take it you're kind of offer the TNC controls for 5-axis machining to create, quote unquote, perfect surfaces with the KinematicsOpt. Can you elaborate on what is involved with that?
Okay, so one thing what is very different between us as Heidenhain making a CNC control, we make an entire motion control system. So that means we're not only providing the CNC, we're also providing the entire hardware, motors, drives, measuring systems for rotary or linear axis, right? Linear glass scales you probably heard of. So that means you have all 5 axes working together at the same time. And when you're using like a 40,000 RPM spindle speed, you want to make sure that your tool center point of your cutting tool is always engaged. Otherwise, you break the tool or you would ruin your surface, right? So in order to make sure that when the machine moves all these 5 axes, we have a cycle what we call KinematicsOpt. And you basically place a steel ball on the table and you have a touch probe in your spindle. And then the machine runs this calibration cycles and measures exactly the pivoting of all axes and corrects if there is any deviation. So that's what the KinematicsOpt is basically doing.
Oh, okay.
What are you saying? Ops?
Optimation.
Optimation. Opt. OPT.
Yeah, OPT.
Okay,
That's
okay.
correct. Yes.
Okay. I just wanted to clarify.
Yeah. No. Good. Yeah. So it's critical, and it's not only for that, but let's say you are in Arizona, and in the morning you are 60 degrees. In the afternoon you have 80. So your machine will grow or shrink, right? So you have inaccuracy. If you use this option, you can run it in the morning at 68 degrees, perfect conditions. You cut your parts. In the afternoon, when maybe the environment changed and you want to continue with the accuracy, you quickly run that cycle to recalibrate the machine to hold the accuracy for the rest of the day. So that really ensures automation. Yeah.
Oh, I gotcha. Oh, fascinating.
Consistent machining, right?
That is incredible. You know, what's amazing to me is, I think I was asking about the AI, if there's much involvement there with any of that.
You know, I think when you talk about machine tools, there's a lot of AI already in place over the years. We didn't call it AI. We call it something else, right? So we had automatic field control, where you're measuring how much material you machine, you automatically adjust speeds and feeds. So that's all machine learning, optimizing without the operator. You're basically machining based on our experience or what's happening in the cutting processes. And so that's somewhat AI already, right?
It's a great point. I mean, it's a great observation because we've had data management, like being able to sort through data so much faster with just even Excel.
Oh, yeah, sure. Yeah.
So when you can cross-tabulate, you know what that means, and right? You know what that means. You did the salary survey without me for so many decades, right? There's an amazing time saver right there. And, if you want to talk about someone who doesn't have experience in the industry, who's got to learn as maybe while they're training, AI has got a pretty significant role to play as an assistant to that person, right?
Yeah, absolutely.
How do you, I'm just going to throw it out there and then we can keep going on Alan's notes, but how does this fit into your training centers?
So there's, like I said, there's certain features and function you have already, what are not really part of the AI term, even though, let's say you want to use tracheal milling, where you're basically engaging your cutting tool 5 times the diameter in depth.
Yeah.
And you move this tracheal milling, right? You need to determine what the absolute perfect feed rate is to engage based on your spindle torque into that material you're machining. And based on that information, you want to give the operator help with that. And we call it OCM.
OCM?
Optimized contour milling, right? And we're using the motion control to measure all this data, and we're putting that into a database where we are basically helping to calculate for an operator who hasn't done this job to just pick out, I want to machine this material, I need to get this surface finish, this quality, this accuracy, and the calculator will automatically optimize and tell the operator or programmer what is the optimum cutting speeds and feeds to machine this material with that technology without knowing a lot about it. So that's AI somewhat integrated into that, even though we don't call it AI.
And it's probably best to call it what it actually is, and it's incremental. It's all incremental.
Yeah.
It's based on, it's essentially comes down, AI essentially comes down to the more experience you have as the user of AI, the better AI is.
Correct.
I'm just going to leave it there.
Oh, yeah, and you mentioned about the optimized contour milling, and which is, and there it's something where it's going to be calculating the best tracheal strategy. I mean, and so what you're eventually going to achieve is a constant chip thickness and reduction in tool wear. What's involved in that calculation process? I mean, how is that?
So that's something
developed?
where we don't talk too much about, because you have also tracheal milling cycles, what you can create in a chem system. And the chem system does basically just a poor calculation, what's the best motion to optimize and remove as much material as you can. Versus when you have it directly on the control, we have much more access to cutting tool data in real life. So we basically, within milliseconds, we know exactly what the behavior of the axis is. Is the axis moving really absolute straight? Are we having a curved motion? Are we going up or down? All these motion in each axis is basically collected by the TNC7 control, and it makes adjustments to make sure that the chip load, what you measure with your spindle torque, is consistent. And it makes consistent changes, so it optimizes this motion, versus the CAD-CAM system goes by the motion. And if you just use that data to machine your part, you get inconsistencies, specifically when you get into small corners and you go really deep and you have problems with chip evacuation. All that can be prevented because the control sees in real time what's happening in the cutting process, and that's where we make the optimization. And that's what makes it so unique. And you can really, if you compare side-by-side performance, you will see there's a significant difference between that system, the OCM on the machine, versus just doing it with a normal tutorial CAD/CAM motion approach.
So it sounds like not only are you boosting productivity, but you're also extending tool life, which sometimes people go for one or the other. But this seems to enable the best of both worlds.
Yeah, you're right. I mean, we did some tests and studies. We were able to cut 4 parts using this technology with one cutting tool, solid carbide cutting tool, versus going with a conventional cutting process. We need 4 tools to cut the same parts. So there's a big increase of cutting cost, or cutting tool cost. Now, coming back to the AI situation here, one thing we also thought about, in addition to this technology, we thought about what is really happening on the cutting tool edge. And we're using AI now to identify, is this cutting tool still sharp enough for the job? Or do we have to bring a sister tool in? The problem is with current methods, how you check a cutting tool, is you either do it outside the machine, you go into your tool crib, you put a brand new tool in, do it on a shrink fit and a collet holder, whatever it is, you measure a brand new tool, gets on the wagon, somebody drives it over to the machine, the operator puts it in the tool changer, and he runs the operation. What you don't know, what happened to this brand new tool between the tool crib, where you checked it, and when it goes into the tool changer. Who says that the operator by accident either dropped the tool or banged it against the door and created a little chip in this, what you think is a brand new tool? So now you're bringing this tool into your work area, you're using the laser, the tool is spinning, and you're measuring the tool, and it still tells you this tool is exactly 10 millimeters in diameter, for example, and is 50 millimeter long. Perfect. But what you don't see is, if you look at the cutting edge of one of the flutes, something broke out because the guy banged it. So Heidenhain developed what we call the VT122, where we can measure the tool, but we can also use camera technology to look at the front or the bottom of your tool, and we can turn the tool flute by flute to inspect the tool if it's really sharp and crisp and is not in any way damaged. And then you can show this in a panoramic picture, and you as an operator can say, I allow a chip in there for 15, 20 microns. I still use it for roughing maybe, but if I want to use this tool for finishing, I'm going to switch this tool out and bring in the sister tool, right? So that's the technology where we use AI in combination of camera technology to improve productivity, but also cut tooling costs. Because if you've been in a shop, Alan, a lot, I've been in a shop, we know what people usually do. They have a lot of experience, they're using certain cutting tools a certain way, and their gut feeling, or maybe their experience says, I can run this tool for 20 hours or 15 hours. And to be safe, I only run it for 12 and I change it out because just to be on the safe side, I'm running overnight. With this VT122 technology, we can now exactly determine when that tool is dull. That could mean you can improve your tooling costs by 10, 20, 30%, because you're really just changing it out when you have to. So you could use your tool longer than you usually do. So instead of running it for, 15 hours, maybe you run it for 17 or 19 or 20 hours. So now you're reducing your tooling costs. So an investment into the system is really an ROI in less than a year, depending on how much tooling you use, right?
Yeah, you mentioned some estimates there, percentages about how much you might save, 10, 15% or more,
Yeah.
right? That's based on your own research, correct? That of customers or tests that your company has done
Right.
to see what kind of impact this might have for a shop that might be thinking about this and like, all right, but really, how much am I going to actually save? How much is this going to, what kind of difference is this going to make for my bottom line, right?
Yeah.
And the difference that the AI element, or let's just say computer element, because really AI is just, it's a computer that can do some calculations that are just incredibly quick
Yeah.
that I could never do. Maybe you can, Alan, I don't know. But what I'm getting at is, it's like, I wish I could think that fast. I wish I could. But it's ridiculous to think that you're going to think as fast as a computer can for the different the different outcomes. But its ability, the computer's ability to just recognize a pattern, and then because it has been fed information already about, if you see this is likely what's happening. And stop me if it's the bourbon talking. Honestly, God, honestly, stop me. But if the computer sees something that it knows now that if this is happening, and maybe we should adjust something right now, so that we don't waste $10,000 on some metal parts that.
That's
We
probably-
suggest
Yeah.
you stop and adjust your process right now so that you can save that 10 to 15 or 20%.
I mean,
Is that-
we don't take it to that level yet.
I am, but am I wrong on?
No, you're right. You're right.
Okay.
That's the next logical step to do that, right?
And that's the goal.
That's the goal. I mean,
Okay.
what is reality right now is that we still bring the human experience into this. Because the human will look at the camera, at the control in this case, because we can connect the camera in the machine to the control. So you can look at that and determine on his own to say, if the cutting edge looks like this, it's not good. And if it's on this tool, it looks like this, it's not good. If it's on this tool, it's not good. The operator has to determine the tolerance band. Is it 15 microns, 20, 150 microns? And then the AI will basically save that picture, how that looks like, and compares it to the next tool or the next occurrence when something is happening. And it will then tell you, you have choices. You can either say, stop the operation, bring a new cutting tool in, a sister tool, and go on with life, go on with cutting, or slow down your cutting speed. You have those, you can program that.
Right.
But there's still the human safety net involved a little bit in that, because AI can make also wrong interpretations, right? And we don't want that. It's too expensive to take that risk. So we want that human knowledge and expertise in there.
I mean, the expertise. I mean, Alan, I just think how many times is like loss of tribal knowledge. I mean, they call it tribal knowledge, a lot of different things, but basically, the Terry Iverson likes to say the Great Tsunami, and that was the first time I heard that, and it was from Terry. But when you're losing all these people to retirement, and this years of built up knowledge, like you can some of the things you're talking about, the older guys out there would know, or women would know that, oh yeah, you're going to run into problems there. You better stop right now. But and in terms of a broader concept of like the workforce development and the skills gap and all that, for anyone looking for a new career or looking for a career, if you're coming out of high school or you're in middle school or high school right now, you don't need years of experience because you're going to be able to learn on the job because of systems like this. But the more you learn, the better you get to advise AI what to do and how to react to whatever AI is telling you about what's going on. I hope I'm not babbling.
No. But I was going to say, you mentioned, talking about expensive. I mean, the raw materials for carbide cutting tools are more costly than ever, and so maximizing tool usage is certainly going to help with that return on investment. Yes. And is that something where you have a ROI calculator? I know you offer that for other areas on your website, for such as the digital readouts, for instance.
Yeah, but we also have calculators on the website where you can look at certain cutting technology information. You can put that in and it gives you how much time or how much money you save if you do certain things certain ways. I think one thing, to come back to the cutting tool usage, one thing you forget about, let's say this cutting tool, carbide cutting tool, costs you $100. But if you're running this cutting tool on a big mold or a big expensive aerospace part and you're just doing your final cut with this tool, what you believe is brand new because it came out of tool crib, but it's not brand new, you're going to ruin that surface. And you maybe have to throw away or remachine a $5,000, $10,000, $15,000 part. So I think it's a combination of saving tool cost, but also a second insurance to making sure the tool you're using is still in a good quality that you can now run overnight and make sure that you get a good part to accuracy and surface quality, right? So
saving you from making a mistake that you aren't even aware of.
Right.
But
that's correct. Absolutely right. And you find out the next morning. Well,
you mean that wasn't a brand new tool?
Yeah, it was.
Well, yeah, and I imagine, are you seeing more lights out machining where people are wanting to, enhance the return on their machine tool investment and not have to hire more people to watch the machine?
Yeah, you're absolutely right. I mean, look, today, if you go to a shop, we can't find people. We're trying to bring more people into the shop, and there's a lot of initiatives out there. But the reality is, one guy maybe has to run 2 or 3 machines. He needs to trust the machine to make a good part. He can't just babysit the machine and try, okay, I'm cutting a little bit more, I do a little bit bigger offset to get to size of my part. Those times are over. Specifically, you want to automate, right? So you need to invest in a machine tool what guarantees you that the first part is right. Because if it doesn't consistently give you a good part, you can automate all day and all night long. At that point, you're just producing scrap because it's inconsistent from one part to the other, where we talked about before with the KinematicsOpt, right? Rechecking the machine, making sure it's still moving accurately so that you really cut consistent parts from number 1 to number 15 or 20 or 12 or in between, high mix, low volume. You need to rely on it. So the operator doesn't have the luxury to stand in front of the machine. He needs to run this one, and that one to make sure that these machines run 20 hours a day, 15 hours a day, 16 hours a day, because the investment is too high, competition is too tough, Asian competition, right? You need to be much more competitive, and you need to do more with one machine. Like Some of the machines now come with jig grinding functionality. So you have one setup, you do your milling process, but then you're switching to a grinding tool and you grind a certain feature without going to another machine, because that's going to cost time and introduces inaccuracy. So all these things playing into today's manufacturing world, where you have operators who, be quite honest, if you have a young operator, he expects to get what he put on the CAD/CAM system. He expects that also that comes exactly like that out of the machine. Not like the older guys, like when I grew up, right? We're looking at, we're machining at it, and we're measuring it, and we said, okay, we leave a little bit more stock, and then we machine it again, and then we got it. Nobody has time for that anymore. You just gotta cut it, and it's gotta be right on. Otherwise, you'll be out of business.
I see. Is there often are you seeing more of a need for some of the touch probes to do some of that measurement work? I know she gave the was it the TS760 with the plus or minus 1 micron accuracy.
Actually, the 750 is a quarter micron.
Oh, quarter micron. Oh.
Yeah.
So you might want to change that on your site.
Yeah. So that's so yeah, you're right. So touch probes, I think, will help a lot with setup, so that you don't have to indicate parts anymore. Specifically, when you take the advantage of a 5-axis machine, and let's say your part is not quite flat, right? You touch probe here on 3 points, and then you use the C-axis to move this way, and your B-axis or A-axis to level and be perpendicular to your Z-axis. So a touch probe can help you with setup from hours to seconds. The newest technology we introduced is what we call model edit setup. And that's really still a bottleneck we're having today, specifically when it comes down to small lot sizes. Let's say you're machining a part on 5 sides,
Okay.
and you're holding on side number 6. So that means the relation of the 6th side to the other 5, when you clamp the part upside down, you now need to either indicate the part, reprobe it in, or build a fixture. But you can't always build a fixture, because if you make only 3 parts, maybe that's not worth it to make the fixture, right? So what we can do now with the TNC7 control, you can bring in the 3D model of the finished part. You place that part, you hold it however you like in a vise in your machine envelope, and you basically virtually moving the machine, or you're moving the part so it looks like about how it sits in the machine. You're looking at the screen at that. And then you use the touch probe to figure out where this part actually sits in space. And the control will know exactly where that sits. So when you then now machine site number 6, or that last feature you couldn't reach before, it blends absolutely accurately within microns into that part. So it saves you a lot of setup time, it helps you with part accuracy and a lot of flexibility.
And less rework.
Exactly right. Or if you have to do rework, let's say you had a part what was you repaired and you welded on or something like that, and you want to blend that back in, you have the 3D model of it, you pick up that part, and now you're machining that last feature, and it blends right in.
Oh, great! This is a good time to fill up. You've got plenty.
Good, yeah.
I gotta say, I do like this bourbon.
It's really smooth. Yeah,
It's
you
nice and
guys
smooth.
picked a really special one tonight.
Well, special guest.
You got thanks. Cheers.
So
Everybody's a special guest,
yes.
really, frankly. But it's really always enjoyable for me to sit like this and have a conversation about machining technology, because I learn as I go. But bottom line is, there are options for careers in this country and worldwide, that most of the world anyway, right? That pay well. I wish I had known how well they pay. I mean, you'd make more than I made when I got out of college and started as a reporter for, I was Pekin Daily Times. I made $12,000 my first year. That was pretty good.
Yeah.
But back in what was that? 82, 83. 83, let's say. But, if you're doing what you want, great. And that was fine for me. I was living the dream. Today, if you're raising a family and you need health benefits and you've got some serious obligations to meet, responsibilities, there's a whole industry out here just waiting for you to notice. And it's unbelievably rewarding. And I know that because the first time I went into a shop and did the video, I just couldn't believe what they were producing inside the shop, just off of Route 12, right up the street. I actually don't know. It was Bolo, I think, somewhere up there, that direction. But ProTurn, I think was the name. And I knew then that this industry would be very intriguing to me from a visual standpoint and from making something with your hands. I mean, because you are using your hands, but I mean, you're making something, whether you're actually making it with your hands or using a machine to make it. So, yeah, I'm starting to babble. You guys got to stop me.
Yeah. But I think you make a good point on that. And I think what people underestimating, I agree with you 100% that instead of going to college, not there's something wrong with that. People are made for college. Others are maybe not. But if you go into a trade where you go into work in a machine shop, become a tool and die maker, go to an apprentice program,
or electrician,
you learn, or electrician, or whatever it is, plumber, right?
Right.
You learn so many things in that training program. What is even beyond that job you're going to do at the end? What I'm trying to say is, people don't even recognize how much money you're going to save at home because you can fix things. You maybe be able to put things together on your own, or fix a little window problem, or realign a door, or maybe do a little plumbing job. That could cost you hundreds of dollars to hire somebody for that. So there's a ton of money you're going to save because you can do things with your hand. And that's becoming as a bonus when you're going into manufacturing. So I think we're underestimating that a lot, right? In your daily life, it's also going to benefit you when you choose to move into that career. And at least that's my view. So you guys can.
I've never heard anyone say that before.
Okay.
And that's really cool.
makes sense,
Alan, what do you think?
Yeah, totally. Yeah. I mean, there's just a lot of ways that you could transfer that knowledge to other areas that you may not even realize. Well, yeah, just, I know you have quite a variety of CNCs. How do you compare and contrast the new Power Mill CT with something like the the TNC7? That one seems to have some pretty innovative features for streamlining and also to basically support every task of the machining cycle.
Yeah, so the TNC7 is really the flagship, right? So that's the top of the line, 5-axis motion control CNC system where the operator can customize the way he wants to see the screen. You get tutorials for the next generation operators or somebody who switches from another CNC control. You can look at a little video clip, how do I do a setup, how do I use a touch probe. There's functions in there to manage your tools a different way. There's favorites, so people can automatically bring up things they always like to use. There's different graphic functions. They can make big windows, small windows. And every operator with a push of a button can look at the control the way he likes to see it. And I think that's the big difference now, that like when you use your iPad or your iPhone or whatever mobile device you use, you try to customize it, what application you want on the front and what you want in the back. And we actually took the same philosophy to attract young people to be in front of a machine, to give them that same power. Not to force them to follow certain buttons they have to push in order that that machine does a certain function. We're giving them the opportunity to say, no, if you want to see a tool table here and your graphics down here and you want to do this first and then that second, go ahead. And the other guy comes in the shop, he pushes his name, and all of a sudden the whole screen changes to his interface. And I think that's what we have to do more. And we see that at last IMTS, we had a long line of people, young guys, kids, who were just fascinated by that type of approach to do that. So that's the high-end stuff. And the good news is, since Heidenhain owns ACU-RITE, who makes the MILLPWR, we're using that technology also on the entry level with the MILLPWR. We don't have all the features. Obviously, we can do 5-axis with that control. We can do 2.5D, XYZ. We can do that. But it's the same philosophy to make it easy for the operator to operate the machine, make it innovative, intuitive. So it's an easy setup, no matter what age you are. If you want to run a machine with 90 years old, it's so easy, you can even learn it then. So that's why we created this product. So it's entry level. Everybody, a hobbyist who wants to get into machining, or has a machine in the garage, he can use it, and he can upgrade, a Bridgeport machine for less than $20,000, for example, to put motors on, drives, into CNC systems. So he turns the manual machine into CNC. Actually, we're going to show that at IMTS. They're going to be a Bridgeport with that new technology we will have.
Is that usually considered something like a tool room lathe?
Yeah, or a mill in this case, yeah.
Yeah.
An e-mill, yeah. Usually that's a tool room, right? But it's also a great tool for schools, right? Because in the school you want to give the students the ability to do the manual machining first and then grow slowly into the CNC aspect of things. And this is really a nice tool to do that.
Why? Why the manual feel?
If you don't have a feeling for how hard material is, and when a cutting tool engages with aluminum or steel or titanium or whatever it might be, if you get that feel, you also maybe get a better appreciation of speeds and feeds when you're running a CNC machine. Because you maybe put 1 0 too much in your feed rate. That could kill that tool, right? Mm-hmm. But if you know, okay, this is really a feed rate, what I remember from my manual days, and it's close to what the CNC recommends or what you put in your CAM system, I think you're much safer operator and much more successful in your job because you have that common sense at that point, right? So,
well, you have the ability to learn.
Yeah. Right.
And from other people's mistakes, if there's data built up,
yeah,
to tell you otherwise, no, maybe that's not a good idea.
Yeah, right. You learn as you go, right?
Oh, God, I know that. Alan?
No, I mean, yeah.
Do you learn as you go?
Always. But I think that kind of covers some of the main highlights that'll be at your exhibit. I mean, if there's anything else that you want to elaborate on.
I think one thing you mentioned briefly, and I drifted off a little bit. You were talking about digital readouts, right?
Oh, yes.
It's still a big market, believe it or not. A lot of people have tool room lathes or simple milling machines where they're just using a digital readout to position, or even a simple surface grinder, right? What we came out with is now a tablet version. So in other words, instead of having a box on every machine, specifically for a school, that can get expensive. We developed an application, what we call droPWR. So it's an application what works on an iPad, and it connects via Bluetooth to your scales, your linear encoder technology you have on each axis. So instead of having a box mounted on one machine and another box on the other machine, for a school, the student can just take his iPad, connect to that specific machine, and can operate that machine based on the iPad. And he also has a benefit of maybe bringing up a PDF drawing of the part he's supposed to machine, and he sees that on the same device, right? So we see a pretty good success with the schools on that, because the investment is lower, and it gives the teacher much more flexibility to have the students go around, or even the teacher can log in into their Bluetooth to look at what's happening here. What is this student doing right now? Is he cutting it to size or not? Or what is he operating on? Yeah.
What's the age that you're talking about when you're talking
I mean,
about
you can go
students?
down to high school level. I think that's where we have to go today.
Is that what you're reaching, the
Yeah,
high school students?
Yeah.
And can you, I mean, the success in schools that you just mentioned, can you tell us a little bit about how involved you are with schools and getting that word out about manufacturing careers?
Mm-hmm. Yeah, so we have special school programs specifically for the ACU-RITE product line, where we offering special school pricing to the school so we can get the teachers into it. On the TNC side, we're offering free training for apprentices when they come to a HEIDENHAIN training class here in Schaumburg or in Fremont. So let's say you have an apprentice and you don't want them to run a $500,000 5-axis machine, but you want to keep them engaged. And we want to help them to keep the interest of that apprentice, to come to us, learn from us, feel secure, feel safe. When he goes back to the shop, he's somewhat comfortable to run that expensive machine without too high of a risk to damage anything.
To the owner.
The owner. And we put so many safety features in there now, where we have collision monitoring, right? Dynamic collision monitoring. So you don't crash the machine, you don't crash into a vise. So you can dry run everything on the machine before you start operating it. And that's very helpful for the schools. Like I said, even on the ACU-RITE side, for the entry level, you can fully simulate, are you really machining in the part, or you just cutting all the way through it? You will see that before you make even one chip. And I think that's our philosophy, to give the operators from every level a confidence to run a machine tool and enjoy what they're doing, because the last thing you want to do is you bring somebody into the industry, he damages a machine, he's frustrated, people yelling at that person, and then he's done with the career, right?
Yeah.
And we don't want that. We want to make sure that they feel confident. We give them all the tools to do that. And I think that's what you have to do today. Because like I said before, people have to run multiple machines. They don't have time to think a lot. They need to trust the equipment. They need to trust the technology to make a good part without damaging.
And so you want to have that predictive protection.
That's correct. Yeah.
Yeah, I mean, it's that predictive correction or observation.
Mm-hmm.
Correction is a perfect word
Mm-hmm.
for not wasting the owner a bunch of money
Yeah.
for whatever shop you're working for.
Mm-hmm.
But I mean, that's a huge benefit for someone who's new to the industry.
Mm-hmm.
That's on purpose.
Yeah.
That's by design that's been developed.
Mm-hmm.
And that's what's, would you say, waiting for anyone who wants to think about a career in machining, for metal cutting for sure,
Yeah.
but most any aspect of manufacturing, right?
Sure, absolutely right. Yeah, I think that's what we need to. We talked about this before, right? We need to make sure that not only the people we know and the people in the industry, we can preach to them all day long, and everybody knows what we're talking about. But it's our neighbors who, don't know that this mold or this glass was made in a mold somewhere, right? Or
Right.
this microphone had to be a mold machine to make this plastic part, or an additive application, whatever.
I made it in my backyard, by the way.
Yeah, right.
No.
People need to understand that nothing they can use in their house, if they look around, has to be machined, manufactured somehow.
Yeah.
It doesn't just come from Amazon.
Terry Everson would love you right now for saying all that, because I mean that's one of the things that needs to be communicated to the entire population, not just this country, but anywhere, I guess. I mean, maybe in Germany, Ireland, and Europe, they know a lot of this stuff already, but in this country, it's still just getting some attention again. Our grandfathers, I think that's the right generation, or great grandfathers for some, kind of knew this already. And they probably recognized that this country was moving away from that when offshoring began in the 80s, 90s, whatever it was. As much as this current U.S. demographic is out of touch with what manufacturing means to this country and to the world, it's probably on the uptick right now, I think. Maybe it's still flatlined for you or Alan, but what do you think?
No, I think there's a motion. I think with companies like SpaceX, Elon Musk, right? I mean, you can like him or you hate him, whatever.
Is that Musk?
It doesn't really matter. But I think people who are celebrities, and if you want to call it that, but innovators and visionaries who talk about technology, building rockets, what are coming back and land. I think people get a little bit more interested in it, and then also try to learn how is it really made. Or just look at Formula One, right?
Oh, yeah.
How that took off when all of a sudden the Netflix series came up. But I think there was also then all of a sudden the notion to say, hey, how are these cars are made? It's a little bit different than a NASCAR. There's some other technology there. There's different materials used. How do they make these cars? And there's also manufacturing involved. So I think you're right in the sense that there's a broader spectrum now where people talk about manufacturing. And I think the kids think it's cool. But it's our job when they come to the shop, and I think that's also important for the shop owners. You want to make sure you expose them to high-end technology. It's not only good for you to be productive and competitive. Don't hold on to these old 20-year-old machines what barely do the job. You got to upgrade, because you're not going to find a kid going in front of a dirty old machine with all buttons to push, screens like this big. They're not going to be excited to work in the shop. So there's a responsibility also for the shops to upgrade, to bring new technology into the shop to attract these young kids. Because if you don't have it, they're going to go to Elon. They're going to go to whomever, right? They're going to go to these high-end companies to try to get a job because they will have.
But maybe it's not even the high-end companies, but your competitor, even if
Across the
you're a
street.
small shop,
Right.
like with 5 employees, shop across the street with 5 employees
And they
might
will.
decide they will do that investment. So, I mean, unfortunately, that's the way of business. I mean, it's competitive.
Sure.
So you've got to constantly be investing. God, as an owner, I understand. Oh, I wish I had an infinite supply of money, but it is the truth. It's the truth. You've got to keep investing in your own business, and that means new technology. technology. Keep an eye on it and stay up to date. So you're going to be able to attract new blood. Okay.
Or even keep your own. I mean,
Oh yeah, right.
think about, the
Yeah.
people who are having experience and they may be in their 40s and they want to learn more. They want to get into additive. They want to get into 5-axis. They want to be challenged. They want to build a career because they have to feed a family. You need to give them also opportunities to get exposure to new technology. And if they don't, then you might lose a good employee. Or he starts his own shop, for that matter.
I mean that.
What is good for the industry at the end of the day, but not good for you as a shop owner because you might lose a really good talent, right? Yeah.
But if you're following what you just said, you're retaining that person if you are challenging them, and that becomes the bottom line. I mean, if you're staying current, it's not about just short-term goals. It's the long-range plan. If you hope to pass the business on to someone else when you're done, there better be someone else there to hand it off to, right?
I hear it.
But this has really been I think a very good discussion. I mean, I hope you appreciate.
No, I really appreciate the invitation and really enjoyed the conversation. It was really interesting, good questions, good conversations before the podcast even. We had, I think, what reflected also in our discussion now. But it's a nice setup. I appreciate that you do it, and I think it's a good way to get the word out and hopefully drive a lot of people also to IMTS, because I think that's something even for the average person to drag your neighbor instead of going to maybe a baseball game. Maybe you say, hey, you want to see how cool manufacturing is? Maybe come down to Chicago on September 14th and check out the biggest machine tool trade show in North America, right? Or maybe part of the world, I guess.
And some people would say maybe even the world. But there's emo, okay? Let's just say it.
Yeah.
But and I know you got to walk a lot more when you're at emo.
That's right.
But I will just to touch on that. You can still go to a ball game if you come down to IMTS.
To both, yes.
Because looks like the Sox and the Cubs are going to be in postseason too.
Yeah.
Although IMTS is the 14th through the 19th.
Yeah, you're right.
What is your booth number for Heidenhain?
Oh, that's 339440 in the South Hall. And then we have a really cool booth, so if you want to bring your kids, go to the Student Summit. There's also a booth at 211634. And we have some cool things, what is related to precision, but also related to fun.
Well, that pinball sounds all right.
Yeah.
Pinball?
So we have a pinball game, and we have, you got to be precise there, right? And,
Sure.
you're going to have a race car simulator, so you have to be precise to drive fairly accurate. It's one of my favorites, obviously. And the other one is the claw machine, so see if you can get a nice price. So that's all for the kids to attract them, because even those machines had to be machined, had to be made somewhere, right? So there's always a relation, and I think this year we tried a different approach. We used to just talk about precision, just bring our control, bring a DRO so people understand how that all works. But the kids want to be attracted to other things like we talked about before, and I think we're going to try this year, and I'm pretty sure we will be successful to do a little different approach.
Total years of your experience. How long have you been involved in this industry?
Well,
Just rough.
Since 84, really. 1984, that is, obviously. So
Really?
we have
No irony there with AI.
So it's when my apprentice program was done. So that's when I would say I really got into understanding what's going on in the industry. And in IMTS, my first IMTS was 1994.
Oh,
So that's also a few years back. And it's great to see that the show is this year really be a big show again, I think. We're probably going to have more than 100,000 people. I know that the registration rate is up by more than 20%.
That's good.
Compared to last IMTS at the same time. So I'm really excited to see it. There's going to be a lot of new stuff there. AI, people from different key industries are going to be there. They haven't been to the show before, I think. So it's going to be a different show this year, I'm pretty sure. And pretty much what you said before, right? That I think there's more people coming from different industries and they're looking for solutions.
Student Summit is a growing aspect of the IMTS show, which is, if you're not familiar with the industry, it's every 2 years, in the even years. So, what year is this? 2026. So that's why, and it's usually in September, right? It's almost always in September. Yeah. So, it's kind of interesting that you're talking about, this the ability to reach students. It's it is a growing aspect of IMTS. You're connected somehow in the background this year, right? Can you elaborate a little bit about what your role has been with IMTS and leading up to the actual show, beyond your role with HEIDENHAIN?
Yeah, right. So I'm part of the IMTS show committee, and I'm doing this since on and off since '98. I think that was my first year to be on the committee. So, so I've seen a lot of changes we made to the show to help exhibitors to save costs and do things a little bit more efficient. Even though I think we're not quite there yet, but we made a lot of improvements, I think. And I think that the show is evolving. There's a lot of more things around it now. There's IMTS Plus now, where people can go afterwards to see more video clips, more information about manufacturing in general, what technologies out there. There's more conferences. I will speak at one of the conferences. So you can learn a lot. Specifically, if you want to get into the industry or start your own business. That's another great opportunity to become an entrepreneur, to open up your own shop, start out with a small manual machine, and then wherever it takes you from there. Because all these big companies need the tier 1, tier 2 suppliers, because they can't just do it all themselves. And I think right now is the opportunity to get into it. If you want to find a business what is going to boom for the next foreseen future, I would say at least for the next 5, 6, 8 years, I believe that there is still an opportunity to start something fresh.
I'm sorry. Do you mean like start a machine shop of some kind?
Yeah, that's what I would say. Yeah.
That's. I mean, I don't know if anyone who happens to come across this online, if not sure that statement is going to have the import that is that the right word, that it should have, because you said 5, 6 to 8 years, right? This is a what do they call that? That tipping point, right? For so many different technologies, but it's also for this industry, and it's itself, because there's the AI aspect and just the progression of technology. I love telling people about this industry, and to me, it's the same way. This is a turning point for so many different things going on at the same time. I don't want to get into politics, but bottom line is, if you were to get into machining right now, you've got a great future. I don't care what happens with a downturn in the economy or an upturn. You're gonna handle it with family, with benefits, and with a good income. Or go to ctemag.com and look at our May issue, because this industry, it could help so many families, so many people who are unsure what maybe they want to do, or if you know for sure you don't want to go to a four-year college.
Big companies like the GEs of this world, they used to have apprentice programs. And they brought people to learn and all that. And they, when they offshored, because the bean counters maybe decided that it's cheaper to produce outside the United States, that's when they dropped this. And I think that's probably something they're also going to bring back. And I think there's some signs that some of these organizations, I know that Ford is doing something again. They have training programs. Boeing is doing had their apprentice programs and things like that. So the industry, I think, is going a little bit reverse, back to the basics a little bit, because they see that there's a need for them if they want to succeed. Even these big guys, they can just hire somebody from the street. They need good quality people who know what they're doing, because if you get on an airplane, you want to make sure that the thing stays up there. Or if you go into your car, you want to make sure that the wheel's not falling off or the motor stalls on you or something like that, right? So you can't just give this to anybody. There need to be a good group of manufacturer people.
Someone invested.
Yeah.
And thanks for bringing Gisbert here today. This has been, I've really enjoyed this, and it's not just the bourbon talking, or the Irish in me talking, and it's not the fact that I'm a little bit German.
So good.
Gisbert, this has been great. I really appreciate your candidness, and you really presented I think a good case, and good objective case for machining and metalworking, metal cutting, and machining and manufacturing in this country, and forget about just this country, but everywhere.
Sure. Yeah, we all have to work together to drive technology forward, and I think manufacturing is key. You can't even build a computer what runs AI or a data center without some manufacturing involved in this. So we got to really get real about this, and people need to realize that. And I think you guys doing a good job of putting this together, getting in front of people. Hopefully people listen in their car, and when they're sitting on the boat or something like that and have nothing better to do, that maybe they get inspired by the conversations we had here tonight. And I hope certainly to see a lot of those people at IMTS and bring their kids and make sure that everybody thinks about manufacturing is important for this country.
Absolutely.
Yeah,
I
definitely.
can agree more.
All right. Well, thanks
All
for
right.
joining
Good.
us.
Yeah, thanks for having me.
I'm just going to close out with a couple of thoughts, and I've kind of already talked about it, but Alan, you're a phenomenal part of Cutting Tool Engineering and CT Publications, Inc. If you didn't know, that was the company that publishes Cutting Tool Engineering magazine and is responsible for the website. Alan is our editor at large. I've always admired Alan's ability to take on any article in this industry and cover it so well. So
Appreciate
I love that. It's great. I think more now than even 2018 when I first purchased this magazine. It's an important moment in history that we are living in right now. Manufacturing is a way to our future in this country and in the world. It's not just about AI. And feel free to chime in, you guys. I don't need to hog the microphone, but it is about progressing our entire world toward something that's more sustainable for everyone. But you have to really believe in what you're doing. And God, I do. I really do. I really believe in this industry. I really believe in manufacturing. I really believe in the careers that it offers. Please don't doubt me. But if you do, come to IMTS, September 14th through the 19th. Chicago McCormick place. Take care, everyone. Cheers.
Cheers.
Cheers.